Hello, Christian Jensen from Woodturning My Way. Today's video I'm going to make a demonstration on how to make a segmented vessel. This is what we're going to make. Now to do this, we're going to start out with a piece of paper and a pencil. I'll show you all the formulas you need to have. I'll show you how to sketch out the edge of the vessel. I'll show you how to cut the segments, how to glue them together, and how to finish it. And we'll come up with this. To begin with, we're going to define our variables. Our out is going to be the outer ring radius. Our in is going to be the inner ring radius. C will be the circumference of the ring. W is going to be the width of the segment. L is going to be the length of the segment. Board length is the length of the board that we're going to use to cut it with. I also forgot to mark T, which is going to be the thickness. The length is how long the outer edge of the segment is going to be. The thickness is the thickness of the board, whether it's 3/4 inch, ½ inch, whatever, but that's what we're going to use. We'll use T for thickness. The width of the segment is going to be how wide the segment is. And we just want to define these so that we're all on the same page. Again, the length of the segment is going to be the long edge of the segment. The thickness of the segment is how thick the wood is. We don't want to get this mixed up with the width. Now the width of the segment is actually how wide each segment is going to be. People get the width and the thickness mixed up all the time, and we don't want to do that. To begin designing our vessel, I take a ruler and a piece of paper and I mark 2 inches up from the bottom. That way we have a square. I then mark out 3/4 inch segments. On this we're going to start out with just 4 layers. Do the same on both sides of the paper, marking off 3/4 inch layers. These will actually be our rings. I then take and mark it halfway down the center of the paper, the other direction. Now here I draw a line. This will be the center of our vessel. Now I only work with radiuses. We're going to draw vertical lines across the page so we can draw our vessel in here. Now we just take a pencil and just sketch out the outside edge of what the vessel is going to look like. Now in this example I'm going to make the walls of the vessel relatively thick. This is only for design demonstration. You can make these any angle, any design, any shape that you want. Again, this is for demonstration purposes only. Now I'm just going to take a Sharpie and outline this to make it a little more visible as we continue on with this demonstration. To decide the length of our segments, we're going to take a Sharpie and just mark out the outer edge of each segment here. Now you can make these really close. This again is just for an example. So we're going to give ourselves an 1/8 or 3/16 of an inch on each side of the segment. You just draw a line up and down until you get to the outside. Now I like to use a set of calipers to measure my lengths. I like to use everything in decimals. Believe it or not, it makes life a little easier. So to begin with, we're about 2 inches. So we're just going to mark 2 on the side. And that's 0 for the inside radius and the outside radius. Here the inside radius is about 1.4. So we'll just mark that down there. Now the outside radius of this one is around 2.35. So we'll just write that figure down. Again, the inside radius and the outside radius. Now again, when you're doing it with this thick of a vessel wall, if you're off a couple hundredths of an inch, it's not going to make a whole lot of difference. Now if you're down to cutting your wall down to a 1/8 of an inch and you don't want to waste any wood at all, then you're going to make these a little closer. But right now we're just learning how to do this. Eventually, when you get a little more experience, you can make these a little narrower if you want. I get most of my wood from a dealership here in town, and it's all scrap. So I don't worry about it. If the thickness is a little bit, that's good. I forgot to number the layers, but this is how we're going to be. Now, a very good friend of mine from Knox City, Jim Burt, has provided me with all the formula that I need to make this work. So right now we're just going to write down these figures. I have a spreadsheet that I've made that I can pop these figures in there and it will plan them all out for me. At this point in time, I haven't got a way to get you a copy of that spreadsheet, but if you private message me, I can send you a copy of the Excel spreadsheet. Of course, I've made several revisions of the spreadsheet since we made this one. For this example, we're using 12 segments per ring. Now, part of the equations, we need the circumference of each ring. The formula to find the circumference is circumference equals 2 pi r. Now to find the width of each segment, we simply subtract the radius of the inner ring from the radius of the outer ring. To find the length of each segment, you simply divide the circumference by the number of segments in each ring. Now to find the length of the board that we're going to need for each ring, I take the length of each segment and multiply it times the number of segments in each ring. And I do this because you're going to need some extra when you're cutting on the wedgie sled. And in addition, I usually add another couple, 3 inches, just to give me plenty of material so my fingers don't get too close to the saw blade when I'm cutting the segments. Now here I simply take my cut sheet out so that I can cut the wood to the length and width necessary. Now before I put my sled on the table, I wipe it down with a good paste wax. That way it slides pretty smoothly. We're going to begin by making a test ring so that we know that the angles on the sled are correct. I take the boards that I'm going to be cutting and make sure I've got them all in the right orientation. Then I take a felt marker or pen, whatever you'd like, and I make a squiggly line on the top. And I turn them up on the side and I draw a straight line down the edge of each one. This will be used so we get everything in the right orientation after we make our segments. Now I've made my own 30, 60, 90 degree triangle out of corian that I like to use to set my angles. For today's demonstration, we're going to have 12 segments per ring. So you divide 360 by 12, that gives us 30. Then you divide that by 2 to give you the cutting angles. If you're using a table saw or a double-sided wedgie sled, then you want to use the full 30-degree angle. Now if you're using a bandsaw or a chop saw or a miter saw, that's where you use the cut angles. I made sure that both arms of the sled were exactly parallel. So if you measure with a device that will measure exactly 30 degrees, and that'll give you a 15-degree cut angle on both sides. You need to be sure to use hearing protection and a full face shield. And I would suggest using some kind of a dust mask as well. Now to start cutting my wedges, I put the board with the line against the bar of my sled, and I trim off the end of that board. As you can see, I have a spacer next to the blade on the zero clearance insert of the table saw. That helps keep the wedges from kicking back after they're cut. I then just alternate the board on both sides of the arms of the sled and finish cutting the wedges. Now you can see the end of my board's getting kind of close to the saw blade. With my arthritic hands, they're not as strong as they used to be, so I don't worry about cutting anything any shorter than 3 or 4 inches. So what I do is I place the piece that I just cut so that the line is up against the same place that the previous piece was. I cut that off and then I just continue to cut the rest of the segments that I need for that ring. I guess I left out the part where I use a disposable nail file to sand off the fuzzies off the edge of the wedges. As you can see, I keep the squiggly line up, and then I alternate each solid line with a blank line on the inside of the circle. By doing this, it keeps the orientation just where it should be. Once I get everything lined up, I secure them with a rubber band. Now when I adjust the rings, I always adjust them so that the outer edge of each segment is in line. As you can see, the ring turned out with absolutely no gaps between the wedges. So now to our cutting list. The list tells us the width of our board is 1.5 inches and the length of each wedge is 1.73 inches. So now I adjust the calipers to 1.73 inches. And put them between the guide blocks on our cutting gauge. I tighten down the knobs. Then I adjust the rip fence so that it just barely touches the outer edge of the cutting gauge. Of course, I forgot to do that this time. Now you need to make absolutely sure that there's nothing between the arms of the sled and your wood. If there's something there and it moves the wood away from your arm of the sled, which is going to change your cut angle. And we trim just a tiny bit off the end of the wood. This is where I noticed my gauge wasn't secure, so I adjusted my rip fence and locked it down. Now I measured it to make sure that the thickness was just exactly where I wanted it. Now I've gone ahead and cut the wedges off the other boards that I had cut out except for the number 4 layer. As you can see, this one is 2 inches wide and the length is 1.05. So I go ahead and make the usual adjustments to my cutting gauge. But when I cut the edge off of this and move the board to the other side, I notice that there's not large enough gap there to get the board in. So all I have to do is move it to the other side. Since the arms of the sled are perfectly parallel, I can just move it to the other side and continue to cut my wedges. Now, since my table saw is sitting in front of the open doors to my shop, I clear it off and just place another sheet of corian over the top of it so that I can use it to glue my segments together. Now I go through and assemble all of my rings and put rubber bands around them. That way I know that they'll all fit, and if I need to make any adjustments to any of the rings. So now I just keep grabbing another bag of segments and I use a little disposable nail file to just kind of take the fuzzies off the outer edge. And again I line them all up with the squiggly line on the top and I alternate the solid line on the outside so that I can get a good measurement. I then put a rubber band around it and make sure everything is lined up correctly and continue assembling the rest of the rings. I deleted showing the assembly of the rest of the rings except for this one. I used Titebond Quickset to glue my segments together. I can just add a little bit of glue to each segment, smooth it out, and stick them together. I keep doing this to each segment until I get everything glued up. Then I put 2 or 3 rubber bands around it and I'm good to go. Now for rings larger than this, you may need to put a band clamp around them. I'm not going to show the glue up of the rest of the rings. It'll all be redundant. Just keep doing it just as I've done it here, and you'll be able to get everything glued together very nicely. Now, I don't have a thickness sander. What I use is a set of coal jaws and a homemade disc sander. I just take this, go down and get some 60 grit sandpaper, put everything together, and start going. I went down to one of the local tool stores here and found a used wrench that happened to fit on there. And I'm able to put it down by the ways of the lathe, and that way it holds it so that the coal jaws don't spin. I keep advancing the quill until I get the ring as smooth as I want it to be on this side. I withdraw the tailstock every now and then and use a gum rubber stick to clean the dust and crud off the sandpaper. This makes my sandpaper last a lot longer. Once I have this side of the ring sanded to where I want it, I simply open up the coal jaws, flip it around, and start sanding again on the other side. Once I get it sanded to where I want to, I just simply remove it from the coal jaws. Now the first ring is quite a bit smaller than the other rings that I've been using, so I need to remove the coal jaws from my quill. Now since this ring was quite a bit smaller than the other rings, I had to make some adjustments to the coal jaws to make the rings fit snugly. I want to take a little excess off of this ring. So I just removed the coal jaws from the tailstock and put them on the headstock. Now for this demonstration, I'm just using a carbide tool. This is not to show you how to use tools or anything else. I'm just showing you how I make segmented vessels. I simply take off just a little tiny bit at a time until I get it down to where I want it. The manufacturers suggest you don't go more than 600 RPM with the coal jaws on this side. When I get it to where I want it, I simply just turn it around on the coal jaws and start again. I know I could use a sanding block to sand that side smooth. That's not the way I like to do it. Again, to make this as thick as I want it, I just take off very fine cuts using my carbide tool. During the rest of the demonstration, I'll be increasing the speed to 5 times normal. Now to get this smooth and as thick as I want it, I'm putting it back on the tailstock, and I'm going to put the sanding block back on the headstock and sand these just the way I have in the past. Now that I have the number 1 ring sanded to the thickness I want, I don't like the way it looks. So what I'm going to do is cut another ring out of a solid piece of oak and make an extra ring that will fit on the bottom. Using my bandsaw, I cut a disc out of a solid piece of oak that's now going to be the bottom ring on my vessel. Now, since this is going to be the bottom of my vessel, I'm going to turn it around, put it back on the headstock, and I'm going to cut a tenon in this to hold it in my jaws. Using a gauge that I made, I mark off approximately where the tenon will be. Now I use a small skew chisel and make a dovetail on the end of my tenon. This is now going to be the bottom of my vessel. So I've turned it around and I'm putting it in the jaws on my lathe. Now we're going to glue what was the bottom onto the new bottom. Now on these, I use a goodly amount of Titebond 2. You can use whatever you like. I prefer the 2. And I let it set for 20 minutes to half an hour before I go to put the next ring on. Now since initially this was going to be the bottom, there's a small dimple in there so that I can center this precisely on the new bottom. Now after that's set for a few minutes, I back off the tailstock and apply another good amount of glue on the next ring. I now place the ring on top of the bottom ring and kind of move it around a little bit to be sure that the glue is distributed equally on both sets. I then have a disc that has a dimple in the middle of it so that I can use it to apply pressure to these rings. And then I twist it and make sure that the ring is centered where I want it, and then I tighten down the tailstock as tightly as I can. After I let the glue cure for a couple hours, I get set up to turn these 3 rings to approximately the size that I want. After getting the outside of the vessel turned down to about where I want it, I move everything around so that I can get into the inside of the vessel and start turning it. Again, I use my carbide tool and I make very light cuts so that I don't get a catch and possibly knock this off. Now I'm going to do the exact same thing for this ring, which would have been the 3rd ring had I not made my design change. I let this ring dry for a couple hours, and now I'm going to turn down the outside of this one to kind of get a general match with the outside of the other rings that I have there. Once I have the outside of this ring turned down, I come back on the inside and do the same thing. Turn it down to where it just meets the other ring. Now, as I said before, this is not a tutorial on how to use carbide tools, but as you can see, I'm twisting the end of the tool just a bit to get an almost a negative rake scraper action. This time we're gluing on the last ring. This would have been the fourth ring, but since I had a design change, this will be the fifth ring. This time I used the disc as before, but since this ring is a little larger, I'm going to add a couple extra clamps to it, just for giggles and grins. This time I let the glue cure overnight, and again we're just going to turn down the outer edge. Now this time I'm going to give it kind of an undercut bevel on this outer ring. And then I'm going to turn the outer portion of the vessel to the size that I want it. Now Michael Woodard, a friend and fellow member of the South Plains Woodturners here in Lubbock, Texas, used this 3D printer to print out this sanding tool, and I really enjoy using it. Now with the tailstock in place, I sand through the grits. I start out about 100 or 120 and go up to 400. Now when I'm finished sanding, I take some denatured alcohol, or mentholated spirits as it's known in the UK, and wipe it down. After the alcohol evaporates, I use a liberal coat of sanding paste and polish that in. Now again, this is the way I finish most of my vessels. If you want to do it a different way, it's up to you. Now after I burnish in the sanding paste, I use a 50% denatured alcohol and shellac solution and apply several coats. Once I have that burnished in, I then add several coats of shine juice. You can find this recipe all over the internet. Now once I have the outside to the desired shape and have it finished, then I come to the inside. Now this is where it can get tricky. For this example, I'm leaving about a 1/2 inch thick wall on this vessel. You can make the wall thickness any size you like. Now again, I clean it with denatured alcohol, apply another liberal coat of sanding paste, and burnish it in as best I can. After I get the wax burnished in, I apply several more coats of the 50% denatured alcohol and shellac, and then I apply several coats of shine juice. I turn it up as fast as I can and burnish it in as best I can. I use a little chunk of mouse pad behind it so that when it gets hot it doesn't burn my fingers. The walls are still pretty thick on this, but again, this is just an example. The next thing we have to do is finish the bottom. Now this is the way I like to finish the bottom. I adjust my coal jaws so the vessel will fit inside the rubber pads Then I take a piece of t-shirt and lay it on the face of the coal jaws, and then I tighten down the coal jaws so that the rubber pegs are just fairly snug around the outer edge of the vessel. Now I place the vessel back on the headstock of the lathe. Now this time when I pull the tailstock up to help hold it in place, I use a little pointier attachment because that will allow me to get my tools in closer to the center of the vessel. Now this is where it gets real tricky. You have to take very light cuts with your tool, and you keep your speed down around 600. Because if you get a catch on this one, it's going to fly across the room. Just ask me how I know that. You also have to be extremely careful here that you don't go too deep and create a funnel. Now I kind of cheat when I sand the bottom of these. I use a power sander. Again, I clean it off with alcohol. I write my name on it and the month and year that I finished it. Now I found if you put a little bit of the sanding paste over your fresh ballpoint pen that the alcohol and shellac won't wipe it off. So I put a generous coat of sanding paste on there and then buff it in. Now to finish the bottom, I just simply go through the steps that I've gone through before. The sanding paste, the 50-50 shellac and alcohol, and the shine juice. I'd like to thank you for watching. I hope you enjoyed it. If you learned anything from this, please like or subscribe. Thank you very much.